What's up? Little sound check. Framing. What is framing? Ah, yeah. Let me pull up YouTube. What's up? All right. Let me grab that share link. One thing I was thinking we could do is also write some documentation. In the meantime, let me pull up what I've been working on. Oh, we want to pull. Okay, they're the same. Actually, want to be on master. Yep. Start. Oh, I think the screen share's broken. That's not good. Let's change it. Change it back. There we go. All right, William. I have it on ultra low latency, and I want to know what the highest quality you can see the stream in is, and if it's worth it, and also what the latency is. Hello. That was instant. Cool. So I think it is instant. Look, test suite's broken. We can fix that. .1080p looks great. Yeah, usually I think it can go quite a lot higher, but I can try to make the font big, even though it's pretty painful. Here, let me clear the desktop. Secret mode, secret mode. Sweet. All right, so I removed some kind of dead options. And didn't update test suite yet. Oh, yeah. And we put messages in a ref cell so that we could not clone a bunch of stuff unnecessarily, which sucks, but that's how it is. All right, and it won't even let me do this. So find. Man. Module dot, do I have anything better? Dot messages dot find. Error count. I guess I only have error count. I don't have any other like helpful accessors. But for test suite, it's not a big deal. We'll just fine. Stupid. Let's try that. Should I put the chat on the monitor that I'm sharing? Is that a terrible experience, or is that good? It's not going to stay on top though, unless we shrink NeoVim. Try something like this. OBS overlay. So it's weird on my, oh no, it's because I'm not live. Cool. Oh, that's pretty close to live, wow. Neat. What failed? I could have sworn I fixed this stuff. These are camel case now. Sorry, kebab case. As B. I think I fixed all this. Maybe I just didn't catch the failures. Well, what should we do? Oh, it's some. That looks great. Assert failed. The internet did not match expected message. This is a B. Why not? Let's just try running that program. Okay, so what this is, we're gonna run test source enum method match never crash. Is that what it's called? And we get an assert failed at line 18. X dot as B is sum. Oh, yeah. And this is supposed to be, I mean, we can go with is none. This is a B. All right, that's what it's supposed to output. Now let's run the tests. So one thing that we changed is if you have a companion namespace for a type that lets you do methods and stuff, you now have to actually say that you're doing that. So right now it's just done by the names being the same, which it still is, but you have to say for. So it's a namespace for square state. And the reason for that is actually to simplify some things in the compiler, but I also think it's just great to be able to, like, you have to just say your intention, and then that way if you mess up, the compiler can help you. So if we try, if you say ns4 square state, but you name this square, states, then it's gonna say like, hey, did you mean for there to be a type here? So yeah, I think it's a bit better. And then ref chess, ns engine, main, ref chess main, ns engine, same idea, ns4 engine. Yeah, it's only if you want it to be registered as a so here, this is the namespace for game state. And you can have multiple still, like nothing's changed. It's just that you have to say for if you want it to actually pick up, and then what it will also do is make sure that it finds one. Yeah, all right, now we're all back to green. If I open up Sandman, which is how I like to grep for this file, I can show you. Let's not do it. Let's do it in another tab, because then everything's gonna work. So let's install the latest. Install macOS from macOS. Let's hope this works. And then we'll actually open the sandbox file in with the LSP working. So the companion currently, what does it do? It lets you use self, and it registers these as actual methods instead of just functions, which just lets you call them with the dot syntax. There's some other things that it does. I'd swear it does something else, but it may be just that for now. Oh, it used to be like for opaque types, or like you could see private things in there. Yeah. But there's no private things anymore. But if there is ever anything like that, then that's where you're going to have kind of access to the internals, I guess. Like the friend concept. So if I open this up, it says ns4 baz. It says unresolved companion namespace. We never found type baz. ns baz is fine. And yeah, now if you def type baz, then that's fine. And if it's baz, then we never found type baz. So it's better. It removes some complexity in the compiler, and then it also, I think, is a little bit better for the user. Get args too, yeah. I was playing around with stringf. This is really fun. So let my args x 10, y, let's do AB. A is 10, B is 20. So if you give a struct to any of the format functions, and the format functions are stringf and writef. So stringf wants a writer, and then your format string, and then your args. And stringf doesn't need the writer. It's just format string, and then args. But what's neat is what I found is even if I already have a struct laying around, I can just use the specifiers. So like I have one in the bindings generator with name and type, and I was able to just do like name and type and pass in like my args. But this is like a thing I already had handy. I designed it thinking we were gonna make structs here, right? And we're gonna be like A is 10 and B is 20, and that does work. you'd like make the struct there and then use that for your format. Let's run this. See, it says hello 1020. And then if I did BA, it's hello 2010. Can I use B twice though? 2010. Yeah, I guess you can. Yeah, it's only if you're positional that it cares about the number of slots, right? To do there. First position and then named. But if I do 3 positionals, yeah, see the third one gets highlighted. So format arg struct only has 2 fields. This whole asks for field 3. But if I were to name that, then it's fine. It'll go positional and then value. And then if you don't want to make a string because you already have a writer laying around like a string builder, then you're going to do writef, and then you're going to do stuff is args, and let's say this was a struct with thing 1 asdef, and thing 2 is bar. Then sb.build, I guess we'll print on sb.build, and then that's going to be stuff is asdef bar. Just goes into the writer, which is efficient because you don't want to make allocate and build a string if all you're about to do is write it out into a buffer. So everything you can do into a writer. So I don't love the names. We have string f, and we have writef, and we actually have write linf. And I never remember if it's write linf or write flin. And I think they'll probably change at some point. I'm leaving them as is, like, so that they have to change at some point. Nope, you get to pass one. The thing after the format string is the thing that supplies your format args. Yeah. I don't see why you couldn't have multiple though. And I guess that's good for when you already have structs laying around, rather than constructing a mega struct, right? And it also can't do nested. So even if you nested them, it doesn't do that. If you want to do that, then just that works just if that expression works. So you would probably just do it like that. If I had a struct laying around called a, then yeah, I would just use interpolated expressions. I guess that's the other thing to mention. All of this also interacts just fine with interpolated. So if I put, if x is just 50, I can still interpolate. Like I can still put expressions in here, and that's 100. And then it's just going to see that there's one positional hole, right? And then this one has 2 positional holes, and now this one has 3 positional holes. This one just doesn't count, and it all desugars to. Well, we can actually look at what it desugars to. Neato indeed. Let's make it small for a minute and make it work. Hey, look at that. The one I wanted to show, though, not the full-on IR, but just the desugaring. So here's x plus x. So this whole string f becomes this. print line. So let builder 3812. So there's only one string builder for this entire thing. And functargs is our struct. It's only going to get evaluated once. And then we push a constant. We call add for I64 x plus x. We push that string part. We push functargs, which is this local, dot A, space B, and then we call build temp, which goes into the thread local bump arena. Yeah, that's a good note though. I don't see why you couldn't have multiple structs here. But because you can do interpolated expressions, maybe it's less important. I'm trying to remember like the main motivation for originally supporting the struct at all versus just doing interpolation. Oh yeah, it's the readability. Sometimes you want to see your format string like non-gummed up, right? And so that's why I wanted to support something like this. You want to see it kind of clean. Like if this is dollars, you know, and then this is like, you know, some like pair with an X. Like I want to see that and not have it be like full of like big old nasty expressions. And I also don't have to make a bunch of like one letter locals so that it'll look nice. So that's why we have this. So yeah. You can't pass a list though. Usually I get like 4 or 5 randos dropping into the stream. And so, you know, if that happened, that'd be perfect. But thank you guys for hanging out anyway. I may just do the types thing. Oh yeah, not randos. We need a we need our restation equivalent, right? A kaboomer. But like with a 1, right? I don't know. So this is annoying. Let x's list event 1, 2, 3, 4, 5 for x's println it index it. What have we done wrong? We've forgotten a closing brace. Okay. 0, 1, 2, 3. Huh. That gave me a heart attack for a minute. 4, 5. Okay. And I can jump to print line. It's actually jumping to iterator because of the overlap problem. Need to fix that. I can jump to x's. So locals work. argc and argv putter argc. If I use argc, I can jump to that. I can find everywhere it's used, even though it's just a local. I don't know about don't know about globals actually. Foo. Yeah, it jumps to the wrong place. It jumps to the old span, but it doesn't do references actually. Interesting. No references found. I feel like that should just be working. All right, so do we make go to definition works, find references. Oh, do I need to save? Find references here. Oh, this is not Ninity. Okay, but the other two usages are. Do we fix that? Let's fix that, and then maybe we'll do types. What I was gonna say is, look, I can't go to definition. I can't do anything with list and int. I can't do anything with any of the types. All right, but that actually sounds more fun. Let's fix the thing with globals. So we're gonna be on declare global. So declare global is called only from one place. This is a happy thing to see, right? 2 of 2, where 1 is the actual declaration, and then this is declare namespace definition. So this is like compile the stuff in a namespace. So we're basically like at the very top level of the compiler, not very deep or gnarly at all. So we're like, for all the definitions that we parsed, we just match on the kind and do the things. We don't always do everything in every phase. So there's some phasing where, we're going to resolve all the types before we do any function bodies, and we're going to declare all the namespaces before we do anything else, things like that. But this is definitely the phase where we declare globals. So we'll go in here, and it's just really a matter of getting the thing from the parser, right? Creating some stuff. So here we're creating a variable and a typed global. So there's kind of two things that come together to make a global, and most variables work this way. They have their variableness, which kind of talks about their variableness, and then they have like another thing that's like where that variable occurs. So there's function param, which also is a variable. There's locals, which like all of this applies, but then they also have other stuff that applies. So for this one, we have the global, and they point to each other. I think the variable ID is in here. I'm not sure if the variable ID, yeah, we have the global ID. So what we do is we figure out what the next global ID is going to be, and then we make sure that when we actually create the global that it works. And I actually have a better function for this. It's called add expected ID, so that I don't have to check this. And basically I'm like, look, I already checked the ID and I'm dependent on this thing getting this global ID. So now I can do that, and then I don't need actual global ID, and I don't need this assertion. So it's like add with expecting ID, basically. Add expecting ID, it doesn't matter. And what that does internally is it's just doing kind of what I was already doing. If the ID is not what we said it needs to be, then we're just going to panic right there. So yeah, they point to each other, the typed global record, and all the things that a global can be, right? And then all the things that a variable can be. So like flags, what do we have? These kinds of things. Here are the 4 kinds, variables. And yeah, we've declared this, and I think we just need to emit an ls entity. So this will be sub.emit language server entity. And the span I'd like to use would be the name span. And I'm not sure. We don't have one, so it's going to point to the let again, which is kind of bums me out. So I've been adding these name spans. So now we're in the parser, parse.rs. So FYI. And then now we're down here, and there's only one place we make one of these, which is great. And then we want to insert it right before. So name span is here, and that's going to work. We have the name token, so this is going to be pretty easy. This is just name token span. And then that's done. So now we have access to a name span. Parse global. We'll use name span, and so why was go to definition working? Because the variable has the span, and the variable def and span, if I use that, yeah, because adding a variable might, no. It's when the variable's used, we emit an entity, and the variable ID is on that entity, and then from the variable ID, it knew how to get to the span. But this location didn't have anything. And then we need the kind, ls entity kind, variable. It's the variable ID. It's all we need to include in the language server entity, because it's going to be able to look up the variable ID, and it's going to get all this rich info, and it's going to see that it's a global. It's going to be able to, if it wants, use the global ID that's on the kind to then do special global stuff if it wants. Like on hover, we can show all of this stuff about the global. Maybe we actually do that. What's the command? Maybe I can just LSP. I've been thinking it's probably about time to work on a website with a bunch of example programs and enticing language. All right, is it a first try? Go to definition, G, D. You can make it vim.lsp.buff. Is that not right? What's it called? Definition. Boom, there. So now you can see it. And find references from here works now. Cool. And if we hover it, it says it's I64 global. So just for kicks, let's go in and enhance that. LSP main. LSP support maybe? I think the hover message. Yeah. It's website time. Yeah, I think it is. So I was working on the bindings generator today, and it honestly just felt really good. A lot of things that I want to fix, and that's just going to keep happening, I think. But just real quick to show one of the things that this isn't done because I'm still figuring out how libclang works and how I want to model this, but I was able to visit struct, like I've been iterating on the return type of visit struct, and it's just really nice that I'm able to have this anonymous struct here. And then this is really interesting. K1 type right now is an either, where for the struct variant, I just define the struct anonymously for what like the struct means. And right now it's just fields, but it's about to have another thing on it. And so I don't have to make a separate, def type for this, but I also want to be able to talk about it. And I'm able to do that by saying, this is the sum type. K1 type.struct means the payload of that variant, right? So I don't have to maintain it separately. And then, the prefix optional I think is nice. This worked out nice with the, I didn't have to spell out the return type of this let because I said returned. If I don't say it's returned, it's like, hey, I don't know what type this is going to be. I would have to write this. And I can actually write this by naming my own function, saying the return type of this function, which is actually pretty cool. But saying let returned is even better because we get, if it were a big struct, we'd get like a guaranteed optimization. But it's also just kind of a nice way. It reads nicely because it's like, okay, this is the thing we're going to return. And it's kind of gross because we have to pass like a raw pointer to Clang visit children. And this is the function we're passing. And then this one felt really good because I could just say, hey, like the raw pointer we get, you know, what type is it? Well, it's exactly whatever visit struct returns. And then I don't have to like make sure that these agree and like get it right because, yeah, I'm just able to talk about, you know, the return type of a function as a type expression. I can also name its args too. If I want to instruct root, that's going to be cx cursor. It's going to be like, hey, cx cursor doesn't have error. So yeah, I don't know. It just felt good. This is a pretty advanced, complicated thing to have to like do all my work through these like function pointers. And then, yeah, it's going well. And then the string building feels nice. So this is the file. Let's see. I don't know if it's working right now. Yeah. So this is what it's doing right now. There's a C file that has basically this struct in it, and now it's spitting out the K1. There's still a lot to do. It's choking on an anonymous struct, but yeah, like haven't run into any like blockers yet, just like tiny paper cuts. Okay, so let's improve the hover of globals. Let's put more in here. Let's just to show. These are all gonna have to be strings now. Very sad. And this is global. And then we're just gonna say, gee, we'll make a block. We'll go global ID. This is gonna be K1 globals, get global ID, just like that, and then global dot. Let's do is mutable or something, is constant. What else do we have? Is exported. I don't know. This isn't what I would actually do. But okay, we'll just LSP that. One thing that's been like super encouraging is that it's not been the case that like development has slowed down and gotten really painful in the compiler. Oh, well, we can say 0 and null. Okay. Let's hover the global. Right. It's constant. It's not exported. Let export bar. Bar exported. Yes, Empathy Monster working on LSP. We just made globals work a bit better. So now I can go to definition, it goes to exactly the right place and find references of the global. Let's do one that's more interesting, K1/OS. This is a global that tells us what the current OS is. So I can find references and I can see everywhere in the core and standard library that we check the OS. Here's a static switch for random. This is also kind of just, I think, a little bit lovely because null terminated arrays are pretty gross. But I mean, let's read this. So this takes us from your classic argc, argv to a span of string. And let me just go ahead and I think it should just be, honestly, I'll just use the traditional names. So buffer from pointer and count, and that this is really C string. There is a type alias. The backend, yeah, the backend is LLVM, and then there is also there's two backends because there's the backend that powers static execution, so compile time execution, and that's a VM that we just wrote. It just runs the IR. So, you know, currently there's like two working plugged up backends. The interpreter, which you don't have to use for compile time execution, like you can use it to run your program, right? So it is a backend. Just happens to be deeply integrated with the, you know, metaprogramming features, and then yeah, LLVM backend. Happy to show any of that code, the LLVM stuff, or the VM, or the IR, anything. Let me get this in a better spot. But yeah, if there's, anyway, so buffer from pointer and count, which is as simple as constructing a simple struct, right? And for each string, we're gonna make a list. Yeah, no, it's fine. I'm here to hang out. So I'd be happy to talk about it. Or we can add types to the LSP. Yeah, so list from mapping, which takes any iterable and then the function. So we're gonna pass that buff in, and then a function over that takes that cstr and then, you know, calls our string wrap cstring function and then strings as span. Like, it just feels like just about as clean as I would want to, you know, to go from argc argv to a span of string. A lot of this code is really old too, so it definitely could be, a lot of it could be written a lot better. But anyway, yeah, let's do types in the LSP. So this is gonna be a little bit hard. I think we're gonna run into some things that are interesting. So one thing that's important is that, like, from the compiler's perspective, this is a type application of list to int, and the result is a new type like list event, but that's not really what the LSP wants. Because if I'm a user and I'm here and I like go to definition on list, I don't care about the fact that this whole thing is like an application to int. I'm really just curious about list, and same thing for like int here. So in a way that makes it easier because we just care about like the atoms, right? But it's just something to keep in mind. We can't just be like, what expression is here? Because it would be this like big one. And we're kind of interested in these little, yeah, call them atoms. So let's start with just a type expression, okay? So well, maybe we can commit first. We just did, we fixed some stuff. Just did the so eval type exper. Let's just start here. Eval type expression, which calls eval type expression extended. This is a nice trick. So Rust doesn't have default arguments or any magic like that, but I find this to be a nice way to solve the problem, where you write an extended version of the function that takes all the arguments that are possible, and then you have the non-extended one that sort of does the default thing. So this would be on a fresh context. So this is actually called in a number of places where we want to do something with our context. So maybe it's not the best place to use it, but there's a lot of other places where I think the pattern's used like really well. Eval type expert, okay. And we're gonna match on what kind it is, and let's just like get the lay of the land and look at what all our kinds are anyway. This is the one I was talking about. Optional is just the prefix question mark. Reference is a prefix star. I don't think I should do this because sometimes the syntax changes. Array, a sum. Yeah, so if we just cover, I think type applications will be like a lot of the way there. This is writing a struct type. So we don't really need to do anything for struct because like I said, what we care about are the components inside that struct. This is actually a really cool thing, these type operators. There's two. Well, there's a few, but struct combine and struct remove, they take two structs and you know, this produces the combination of the two structs. And then this will remove the fields in B from A. So like you can do in TypeScript, structural typing stuff. Since we have structural types, we can do all of this. And I've started to do a little bit of it, but it's like just only kind of scratching the surface to how much you could just do at the type expression level, which is neat. I appreciate how you program by hand. I think we all have AI fatigue. Yeah, definitely. I've programmed a lot with AI too. And yeah. I'm not using it now. I do talk to it a lot. It's just got really bad taste though. So for design decisions, it's really only useful as like a temperature creator. Like stir things up, you know, get you out of your own stuff. But yeah, really. Like when you ask it for help design on like syntax design or like cohesion, it's so bad. It's so bad. It's got no taste. And I had it build a few things in the compiler that I did regret and kind of ripped out and had to do again. Like it initially plumbed through the array types, which caused me like not to think through a lot of things about them and miss a lot of opportunities. And like I was really mad. I was like telling my wife as it like spat out the array code and I like had it write tests like, this is so neat because like I can take care of the baby and like make progress on the compiler. This was like 6, 7, maybe it was like a whole year ago now. And it was kind of nice, but over the next 3 weeks I replaced the entire, everything it did for arrays. Cursed lang. Let me see. I wasn't prepared to pull up a browser, but I think I can do it. To go into safety mode. So I'll have this here. All right. Cursed lang. Well, didn't they just this made me so mad. Zero lang Vercel. They're like, we made a systems language. Oh my god. And it's got 4K stars. And all they did was it outputs diagnostics in JSON. As if an LLM can't read like formatted text. Like there's nothing special. Meanwhile, there's other people saying like we invented something that LMs are better at than JSON. But it's for agents. Intentionally unstable. Show me some zero code. Examples. Resource CLI. Rescue missing. That's kind of nice. It looks a lot like K1. And it also looks all like Zig and Rust because, yeah, none of it's original. Yeah, the .0 file name is sick. Submim EQL, this is very Zig, right? Error tour. How is that an error tour? There's just shit everywhere. It just puts stuff in places. Storage. Okay. You alloc your storage. And now if first dot has compile time. Meta. Has field. Shape. C interrupt. I wonder I wonder if it's real. You know? These are examples. Do they work? Yeah, it's by Vercel, so yes. Definitely, it's, yeah, fully vibe coded. Hosted HTTP client runtime 3 days ago. Void raises. What is .has? We're gonna go look at the compiler. Wait, where's the source? And how fast is the compiler? 0C? Maybe this is it. Emit elf. Holy shit. Why are we freeing HTTP stuff? In the elf emitter. A lot of magic numbers in here. Look at this. I mean, if they can make it work, it's amazing. There's just so much, right? Like, I'm happy to be proven wrong. It's just not. It hasn't been my experience. I guess it's written in C. How's the parser? Push interface. Yep. Parse postfix. Parse primary. While true. Dots. I mean, this looks like a good parser. at first glance. It's not a very big parser, especially given that it's written in C. It's a lot of freeing things. Ooh, have you heard of arenas? Holy shit. Yeah, so like this is probably all, I guess it's all going to be from the initial commit. Yeah. Strengthen generic direct specialization. Sorry, it's a detour, but I've been wanting to look at this. Yeah. I don't know, guys. A lot of people contributing. Summary, source, changes, conformance, proposed changelog line. Ay, ay, ay. Why? Why? I mean, maybe it's like an open issue. I don't know, but tell me why. Let's see. This is regularity over cleverness. Safe environments only. Pre-one by design. One obvious path. Exploration over mastery. Standard library over sugar. The most useful feedback is what helps agents work with less guesswork. The most useful feedback is what helps agents work with less guesswork. What? So it's not a language for agents. It's a language by agents. And they put in the prompt to make it for agents. And it outputs JSON. I don't know. I think it's really cool that they're doing it. I think a language for agents has to be, yeah, I mean, maybe I could spend a long time talking about that. I think it's important that the text conveys what's happening, like as much as possible. So like the less polymorphic, or at least like not intensely polymorphic, the better, right? So like closer to like how C and Zig and Odin like will look, right? Because like all it has is the program text, right? So I think that's really important. I also just think it, if compile times are really, really fast, then agents are going to do much better because they can just invoke the compiler constantly, and they need that feedback. That's what anchors them to reality, right? The actual program, the actual software that checks, right? So it's just a great pair, a real compiler with an LLM. So yeah, I think just if you can compile really fast and run really fast, that's going to be the best language for agents. So, maybe not Rust. Rust, like, your agent's going to spend 9 hours, like, fixing lifetime problems, right? Okay, eval type application. So there's two cases for type application. And with a type application, we're talking about, like, someone is calling a type, right? And the thing about type application is it may or may not have arguments, okay? And if it doesn't, okay, actually, I'm getting a little bit ahead of myself. Yeah, it's a generic. Yeah, I guess only for generics does that matter. The first thing we do is a little bit of magic around like multi-pass phase stuff and recursive types, recursive definitions. So we have this definition stack of like we're currently checking. I don't know, I can show you recurse. I mean, like this works, right? But if I remove this star, it's going to reject it because it'd be infinitely sized. And type directly contains self, right? And the way it does that is like it counts indirections through this layout depth thing, and it like increments and decrements it. I don't think we need to worry. I guess we could admit what's the type ID again? Yeah. Let's do it. Let's just do it. Ah, right. So we know there's no args. Cool. And this is like a big problem. This is like one of the last hard things I really need to do is recursive generics. Okay, yeah, we don't even have type. Could it really be that simple? We'll add more things if we need them. So that's going to be a type for sure. And then also not recursion, fresh layout depth, blah, blah, blah. We go again. Okay, so that's if it's unresolved. And then if it's generic. Ah, and then all other types. I missed it down here. It's like, wait, where? We have this, we have the unresolved case, then we have generics. Where's like just like all the types? Everything else. Get type ID resolved. Okay. If it's a type param, like, you know, tick-t or something, then we have to check if that has been bound in the scope. And so only after we do that would we want to emit the entity. Otherwise, we'll just point to the variable, I think. See you, empathy monster. It's a cool name. What's your thing just says GNU Linux. It's pretty cool. What's your favorite GNU project? Mine is M4, the macro thing. I think if I could just put M4 in K1 as the preprocessor, I would. I'm going to do something like that. Look at this. This is a tangent, but like, look. So for the bindings, right? Like everywhere that we have to say extern clang underscore the actual name, fun the actual name, right? Like this whole part. Like I want to write a macro for that. I can just be like clang def, and then I can just say get cursor display name, right? And then from there, cursor, ZX cursor, right? A regular function definition, right? Like, I think that would be sick. It can save you so many features if you do a little like actual text-based function expansion macro system. How would we do this? I think it would be like, not a rewrite, but let's just say it was like def rewrite, right? And it would be like, the name is clangdef, and it's gonna be like name, and then like there's not even, you don't even need a type here because it's all just like text or whatever, or like token, right? So it'd be the next token. So it'll work off, you know, what the lexer considers a token. Where are we? Oh yeah, this ID. So token kind, right? So, you know, we would document the lecture. You want to do this anyway because you want to be able to write macro token stream based macros so that like people can use your lecture but write their own parser. So you could just like write XML in K1 file. And what you do is you just say, hey, here's my macro, and it takes in token stream, and they consume basically K1's lecture stream. This is what Rust does. You can do like, what's it called? It's called the TT muncher, actually, a macro that just like walks the token stream. But anyway, so you do this. So that's going to be a token, and then fortunately that's one token, and then it's going to expand to, right? Exactly, and then we need like some way of doing interpolation, right? Maybe we would reuse what we already do, but it's like it's in here is a totally different language, right? So it's not the same interpolation, but we could use the same syntax. And then fun, and then name again, and then like that's it, right? And then like we're done. So how would we say we're done? Like, I don't know, the whole thing expands to like this. Wouldn't that be, I mean, I think it's good. People hate on C macros, but like, I don't know. Just like let people do what they want. You can do it to dry up a lot of like local repetitive code too, like anywhere that the language kind of fails you. Or you want to just be a little bit more like text-based. And the names of the types. Oh, for the params. What, like ClangDef, I would use it like this. Right? I don't know how you would call it. Would you call it like that? And then this expands to that. And so then we just pick up here, like with what we had already written, right? I'm only replacing this. I don't know, I need to read some of the sacred lore. I just think there's a reason that the greats in the 70s and 80s like put a macro system in everything, like a text macro system. One day. Wait for me. Love. The whole span of the type application, actually we can do a bit better. Tyapp.name.span. That's going to be just the actual name, not like the whole thing. Although in this case, I think it's the same. And then for a generic, well, we're going to evaluate each of these arguments, right? This is like list of t, right? So this is where like we evaluate what t is, list of int, right? So this ended up being int, and that's going to be also an entity, right? And this is going to be the parsed arg span. It has a span, thank goodness. Type arg type ID. So for all the args you pass, like that's also a type that we've named. And then for this, the name. So it's a generic. If we actually succeed, we successfully check constraints. We're going to come down here, and then we're going to emit an entity to point at the generic type. So in our example, that's list, right? Let's pull up the Sandman. So we just emitted for these. Now we're going to emit for this. I don't know how I did that. Okay. Did you know that Vim has built-in man page, but you just have to capitalize it, the M? Man, mmap. Boom. Here I am. Man, Fopen. What do y'all think we should do? Next time it could be fun to have a project, right? Like, should we just like make a Lisp in K1 and just crank on that on a certain night of the week? Or is it more fun to do real work on the language? Maybe just to mix the things. I don't know. It'd be fun to make something. Yeah, in the Lang. Yeah, we could have a project that, I don't know, features of the Lang that I don't work on outside the stream or something. Maybe when we do the bytecode in the VM, the actual lower level bytecode. I don't know. There's lots of to-dos. Maybe we'll just do fix me roulette, and we'll just do it like that. We'll just pick a random fix me. So this type is going to be the type of the generic. So we looked up something to get to this generic, and it's this type ID. Yeah, that's fine. Does LSP count as stuff in the Lang? Is it like legit enough? I feel like it's really important. We'll do the namespan. We'll just call it the namespan. Namespan. Oh no! Oh no, we're borrowing self in here. And that means that this type application, right, that we got from the AST pool, like, might be gone by the time we finish. What a disaster. So here's what we do. Oh, we already did it. Let namespan. Yeah, we go to jail. You go to jail. Fix the borrow checker error, or you go to jail. Claude, fix. Half of the lines of code in this 18,000 line compiler are locals to prevent borrow checker problems. And it actually is doing a meaningful thing, because when I wrote tieapp.name.span down there, that is actually dereferencing, like tieapp is a pointer, right? And when I do this, what we're saying is it actually will make stack space, and it will put the span ID on there. Like it'll put it in a local on the stack, and then it's not dereferencing that like that heap pointer into the AST tree, right? So it is meaningful. Like it actually does physically do something different. It's just like the fact that this literally can't ever be reallocated because it's inside my virtual pool that is mapped and grows forever. I mean, of course, like Rust doesn't know that, and of course, like we could just like do whatever we wanted to that memory in the meantime. Like, I get it, but anyway. All right, so now deciding what we want to do for types is going to be, we're now in the LSP and we're in find references. For now, I think we're just going to do nothing because we don't have usages. We don't report usages of types yet, although we may end up doing it exactly where we just were. These places where entities, this might become register type usage instead. That'll emit the entity and increment the uses of that type, maybe. But for now, we'll just do that, and then we'll go in LSP support. So hover message for entity, great. We'll do type. Let type, and that's going to be K1 types get type ID. Now we have a type, and what do we want to do with the type? K1 type ID to string. Oh, we don't even need to get it, do we? We'll just do our full type ID to string. We can do more later. Oh, let's do the... I think I do have like a size info. Yeah, size align. Let's do this. So this does rebuild the string, but we're talking about a hover request. So we have a budget of about like, we could do 50 million of these and still be fine. But in hot code, what I would not do this. I would not make this string, allocate it, and then make this string. What I would do is I would format it all. I would do it all in one format call, and I would call my version of type ID to string the display version that writes into a writer. But this is not. This is not hot code at all. So it's fine. Oh my gosh. All right, we have to borrow the entire compiler as mutable because get layout sometimes computes a layout. All right, and then the definition span, this is easy. Typer, it actually has like get span for type. Get type, there's like a type span. Type defin span, definition span. I don't know, there was something like that, but it doesn't really matter. If it's types, oops, types. It's like origin span. There's some bit of code that cares about where a type comes from, and I don't. Anyway, defin info. Fast ID. Span for ID. And if there's not, then I don't even know. Where do we get a type span? I think I took the spans off of them. Maybe that's fine. I mean, some of them will, like a lambda. Oh, wow. I'm not even allowed to return none. So types that don't have a definition info. Which types don't have a definition info? Anonymous ones. Yeah, I'm just not storing. See ya. I'm gonna go soon too. Thanks for coming. We gotta get more kaboomers in here next time. Website will help. Thank you. I think the recording will be good too. All right, I don't have one. I definitely could have one. Isn't it nil? No, we'll do that. I think I just prefer to do an option of a span. We'll do it like that. And then now, oh, never mind. I was already checking for none. Great. I don't know. No idea if this is gonna work. What do you think? Go definition. First try. Can I get a first try in the chat? I'll do it for myself. First try. And now let's go to int. Yep, there it is. But it's going to the def type. It's not going to the name. Because the defin info. That's just a matter of how we do defins. I think I could actually just change that. Parse definitions, type definitions, right? Span. So let's go to making a parse type defin. Happens in one place. And the span is the entire span of the type definition, which is fine. We could do a name span here. I feel like it's probably worth it to do the name, just do a separate name span. It just may be useful to have the full span. I don't know when it would be though, but whatever. No, you know what? I'm just going to do this. The span is going to be the name span. And that's final. Oh no. You expect kind ident. Name. Token. Name. Boom, 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 boom. Ready? To the name. To the name. That's too good. Find references does not work. Hover is back to giving us. Ooh. Now that's interesting. Because on this hover, what I actually want is to know that we applied it to int. So I can emit an ls entity called, I can still do a type, and I can provide the root ID, same as I'm doing, but then I can also, I can provide more info, like say that it's an application, and then do the applied ID. That might be best. So here, right? I think having a root type and still always doing that is probably great, rather than it being like, you know, type and then type application. There's gonna be a lot of overlap and stuff. So like we just do this, but we could say applied type ID even. Let's try this as a parting shot. Ready? So it's gonna be none here. It's gonna be none here, right? Or do we rely on this? Maybe we rely on that to emit this one. Yeah, we sure do. Because that's recursing. And then this is going to be, right? Yeah. All right. And now we're going to do this. And this is going to be instantiated generic type ID. It's just instantiated type ID. Like that. And then what I'm going to do is I'm going to emit an entity, and I'm going to say that the applied type ID First try. Okay. So now when we hover message, nope. Is that it? Well, then we need the layout of the applied type too. Applied isn't even right. Yep, but we need find references. That's like usually where most of the work is anyway. Oh man. That feels good. All right. I'll take the W. That is it for me. Support LSP types. Hover and go to definition support. Yep. There's no find references, yeah? Yeah. Let's make sure nothing's broken. The computer is usually faster. Yep. All right. We just failed on no commits. Sweet. All right. Thank you all for watching. See you next time.